All right, number 17. This one is similar to difference of squares. You'll see that the middle terms will cancel. So we're going to FOIL. And we get this first term, square root of 49, outer, minus the square root of 35, inner, plus the square root of 35, and last, minus the square root of 25. So those middle terms cancel. The square root of 49 is 7, minus the square root of 25 is 5, and 7 minus 5 is 2. Number 18, we have the square root of 13 minus 2 quantity squared. Remember, the exponent tells you the number of times to multiply the base times itself. So I'll just write it out twice. The square root of 13 minus 2 times the square root of 13 minus 2. And then I will FOIL. And you get the square root of 13 squared. 13 squared, I think, is 139. I'm sorry, 169. All right, so we have the square root of 169 minus 2 square root of 13 minus 2 square root of 13 plus 4. Square root of 169 is 13. So now I have 13, and then I'll combine these like terms. So that'll be minus 4 square root of 13 plus 4. And now I will combine these like terms. And so that is equal to 17 minus 4 square root of 13. Number 19, 7 plus the cube root of 6 times 7 minus the cube root of 6. Again, this will be like the difference of squares. The middle terms will cancel. So I'll FOIL. First term gives me 49. Outer, minus 7 cube root of 6. Inner, plus 7 cube root of 6. And last, minus cube root of 6 squared, which you could write as 36. So those terms cancel. So that's 49 minus the cube root of 36. Number 20, we have the cube root of 108 m cubed over n to the 5th. So what I'll do first is I'm going to separate it, but I'm also going to write this in terms of perfect cubes. So the cube root of the perfect cube within 108 would be 27. So 27 times 4 m cubed over the cube root of, and I'll write this as n cubed times n squared. All right, so now I'll take out my cubes. The cube root of 27 is 3. The cube root of m cubed is m, so 3m cubed root of 4 over the cube root of n cubed is n, and I'm left with the cube root of n squared. Now, I cannot leave a radical in the denominator, so I have to rationalize. I want to have a perfect cube. I have 2 n's, so that means I need one more. So I'm going to multiply by the cube root of n. All right, so now that will equal 3m cube root of 4n over n times the cube root of n cubed, and the cube root of n cubed is n times n is n squared. So the final answer is 3m cube root of 4n over n squared. All right, 21. I have 1 over the square root of 2 plus the square root of 7, and I want to rationalize this binomial denominator. So I'm going to multiply by the square root of 2 minus the square root of 7, in both the numerator and denominator. All right, so in the numerator, 1 times anything is itself, so I have the square root of 2 minus the square root of 7. In the denominator, I need to FOIL, so that'll be the square root of 4 for first. Outer will be minus the square root of 14, inner plus the square root of 14, and last minus the square root of 49. The middle terms will cancel. The square root of 4 is 2, so now I have the square root of 2 minus the square root of 7 over 2 minus the square root of 49 is 7. And then combine like terms, so that'll be the square root of 2 minus the square root of 7 over negative 5. And you can leave it that way, or you can distribute this negative up through the numerator and make this negative square root of 2 plus the square root of 7 over a positive 5. And I'll accept either answer.